Hydrodynamics, the science of fluids in motion, is pivotal in a myriad of disciplines. At its core, hydrodynamics focuses on how liquids, especially water, behave when they're in motion. The fundamental principles are governed by the laws of physics, encapsulated in equations like the Bernoulli's equation, which relates pressure, velocity, and potential energy in a fluid flow. Fluid properties such as viscosity, density, and surface tension play an integral role in determining a fluid's behavior. Viscosity, the measure of a fluid's resistance to flow, impacts how fluids like oil and water move differently. Density, or mass per unit volume, is crucial for understanding phenomena like buoyancy and pressure distribution. Surface tension, the elastic tendency of a fluid surface, affects phenomena such as water droplets forming and insects walking on water. The Navier-Stokes equations are the cornerstone of hydrodynamics, describing how velocity changes within a fluid under various forces. These equations help predict weather patterns, design aircraft and ships, and even simulate blood flow in the human body. Flow patterns, such as laminar and turbulent flow, are essential concepts. Laminar flow refers to smooth, orderly fluid movement, typically seen at lower velocities, while turbulent flow is chaotic and occurs at higher velocities. Hydrodynamic applications are vast, from designing efficient ship hulls to predicting ocean currents and understanding the movement of pollutants in water bodies. Engineers and researchers utilize hydrodynamics to solve problems in environmental science, civil engineering, and even biomechanics. By mastering these principles, you gain the foundation to engage in meaningful conversations with experts, whether discussing marine engineering, environmental conservation, or aerodynamics. Like and subscribe for more videos like this.